And again, the general format for the equation of a circle?
X minus h squared plus y minus k squared equals r squared.
So, how many variables we got there? 5?
Yeah.
If I plug in that for x and y, I will have 3 variables. If I do that 3 times, I will have 3 equations and 3 variables. If you get the same number of equations as you have variables, you can solve it.
Oh, okay.
That's the only way I can see how to do this. Let me take a look at what your teacher did. Yeah, that's what he's doing also. In other words, there's equation 1, and somewhere 2 and 3 are going to come along. But let's do it. What's my first equation going to be?
So negative 17 minus h squared plus 1 plus 7.
Hold on. 1 minus k
Oh yeah, 1 minus k
squared equals
R.
r. There's equation number 1. What's equation number 2?
Negative 17 minus 8 squared plus 13 minus k squared. Or, yeah, so equals r squared.
Okay. And that's not enough to solve it because I still have 3 variables and only 2 equations. So what's my third equation need to be?
Negative 15 minus 8 squared plus y minus 15.
Oh.
Or 15 minus k squared.
Okay. In other words, if you make a mistake and stick a y in there, we're not going to be able to solve it. We've got to have the same 3 variables. And I have 3 equations and 3 variables now. I can solve this. Now, the question is, do you know how to solve that?
No.
Okay. Well, let's see. There's got to be an easier way to do this, but what did he write? Is this writing down here for this problem 3?
No, that's for number 4.
So this is all problem 3 here?
Yeah.
I see a 1, which is that first equation. Right there is first equation. Ah,
okay.
No, you put plus 7 instead of k. So what's written down here is not correct. In other words, minus 17 minus h squared is correct, but then it should be plus 1 minus k squared equals r squared.
Okay, so I'll just
not 1 plus 7. I don't know where you got the 7 from.
I'll just erase all that.
Okay. Let's just solve this, I guess, the hard way. It'll take a while, but not that long. Expand each of these. Let me write it below. We're going to run out of room quickly here. So let's write equation number 1 again. Expand it.
What do you mean?
We got terms that are squared here. For us to solve this, we've got to we've got to expand it. In other words, I got to make minus 17 minus h squared, and then I got to do the same thing to 1 minus k squared. So what is minus 17 minus h quantity squared?
Plus 17 times 17.
I'm wondering if there's an easier way to do this. No, I think so. You have a calculator?
Yeah, hold on. Uh, 289, or, yeah.
Okay. Keep going.
Plus 17h.
Actually, it's
Or minus,
2
yeah.
times 17 times h. In other words, that the next term would be minus 17 times minus h, which is a positive 17h. And then the term after that is going to be minus h times minus 17, another 17h. So that's 34h plus h squared. Keep going.
And then k,
Expand that.
or 2, or no, 1,
Okay.
plus k, or,
You want to get to where you can do a binomial expansion quickly. In other words, you don't always want to have to FOIL that. I'm not foiling that. I'm doing this based on memory. That is always that, and this is always this. Notice the similarity. The only difference is the middle term. The advantage of having these memorized is that if I give you a problem, say 3x plus 4y squared, I can use this right here to do it. A is 3x, so that is 9x squared plus 24xy plus 16y squared. Much, much quicker than having to FOIL it. And especially when you have problems like we're looking at, where there's a lot of binomial expansion needed. So you want to get to where you can do this based on your memory of those. So I know that when I expand 1 minus k, I'm going to get 1 minus 2k plus k squared. Okay? Equals r squared. Okay, let me remove the parentheses. Don't need them. And combine everything. So equation 1 becomes h squared plus 34h plus k squared minus 2k, and the numbers are plus 290 equals r squared. That's equation 1. Seems like an awfully difficult way to do it, but I can't right offhand think of a different way. Is this basically what your teacher did in class?
She didn't show us this. She just like put up a key
Almost
on
has
the board.
to be, because what you're essentially doing is you're saying that there is a circle that goes through those 3 points. Well, what's the equation of that circle? I'm not going to be able to figure out the radius directly. I'm not going to figure out even where the center is. So the only thing I can really do is put those 3 points into 3 equations and solve for h, k, and r. And then I'll know where the center of that circle is and its radius, and I'll know its equation based on that. So that's the plan. Like I said, I don't know that this is the easiest way to do it. So let's expand that. It's the same expansion, so I don't need to do any work. So that's still going to be 289 plus 34h plus h squared. But then when I expand this one, I get what?
Um,
13 squared.
what am I?
13 squared is 169. What's the next term? I'm expanding that.
You're expanding what?
13 minus k squared.
So then,
First term is 169, 13 squared. And then I have 2 times a times b. Well, that's 2 times 13 times k. So that would be minus 26k plus k squared equals r squared. Okay?
okay.
This is going to actually solve pretty easily. Now let's rewrite 2 in the same way we rewrote 1. Let's put that there, this here, and combine numbers. We got 289 plus 169. That is, in fact, let's write the k squared and the minus 26k, and then put that number at the end. What is that? 458. And now equation 3. I hate these problems that take 30 minutes to solve because it doesn't give us time to cover the other ones you need to work on. Okay, so let's expand 3.
So
15 squared is 225. Plus what? How many h?
Negative 15.
Remember, it's 2 times this times that. What is that? It's 30h. Plus h squared. Now expand the 15 minus k squared.
So it's 225, and then plus
minus
30k.
minus because it's a minus there. In other words, when you expand a minus b squared, you get a squared minus 2ab plus b squared. So I get 225 minus 30k plus k squared equals r squared. Okay? Now, these are actually going to solve fairly easily. You'll see why. First of all, let's rewrite equation 3 as h squared plus 30h plus k squared minus 30k plus 450 equals r squared. Okay? Now I'm going to erase the one that is not ordered properly. You with me?
Mm-hmm.
And now I have these three equations to deal with. And you'll notice that I can do these by elimination fairly easily. What happens if I subtract equation 2 from equation 1?
All that's left over is 24K and negative what is that?
Well, it's
Negative
158 plus 10, so it'd be 168, but it would be minus, because I got to take it on the other side after in other words, it really would be this. Plus 168 equals 0, right? Because the r squareds disappear also.
Right.
So from that, you can solve for k.
Okay.
Okay. Once you solve for k, now you can work with the other two equations and solve for h. Notice that if we manipulate equations 2 and 3 and subtract 3 from 2, I'm going to lose. Well, let's do it. Well, first of all, let's finish solving for k. What's 158 divided by 24? That must be 7. K is minus 7. With me?
Yeah.
Okay, let's erase that so I have room. Now let's manipulate equation 3 and 2. Which is the best one to subtract from the other? How about we subtract 3 from 2?
Okay.
What does that give us?
That gives us negative, or 4H plus 4K.
Huh?
And then minus 8.
Well, it would be minus, yeah, you're right, minus 8 equals 0, right?
Right.
Well, we know what k is. K is minus 7. So now we have 4h plus a negative 28 minus 8 equals 0. So 4h equals 36, h equals 9. H equals 9. We're 2/3 of the way there. Now we can go into any of these three equations, substitute for h and k, and solve for r.
Okay.
The easiest one to do is probably this one here. It's got the smallest numbers. So let's see, this would be 81. Wow. I'm not sure I agree with putting these kind of numbers in here to teach this because it just takes you too long. It takes up too much time. Got a calculator? Add all those numbers up.
Okay, hold on. So it's 740.
Take the square root of that, and that's actually that's enough. You don't really need to take the square root of it. In other words, once you solve for r squared, you're actually done. Because remember, the general format of the equation is equals r squared. So I don't need to worry about taking the square root of 740. I don't really need to solve for r. So what is my equation going to be?
Is it just x minus 7
What's the
Plus 7.
H coordinate? First of all, which goes with X?
9.
H or K?
8.
Okay, so what comes next?
So 9.
Okay.
And then y plus 7, because it's negative.
Equals 740. There's your answer.
Okay.
Okay? And that's the only way I know. I haven't run into a problem like that in quite some time where you're given 3 points of a circle. It's a hard solution. I mean, that took us 20 minutes to solve. All right, let's look at number 4. What is number 4? Kind of gives you a hint as to what it is with the questions. Vertex, focus, and directrix. What are we looking at?
A parabola.
Okay. So is it a sideways or a vertical parabola?
How do you know that?
Because if you think back to your first introduction to a parabola, that was it right there, right? That is that parabola. And it's y to 1 power and the x is squared. If you have x equals y squared, that is a completely, we've never seen that before. That's because that's not even a function, but it is a parabola. It's a sideways parabola. So it depends on which variable is being squared as to whether you have a vertical or a horizontal parabola. Well, we can see that the x is being squared and the y is not. So we have this situation here, a vertical parabola. So what is the general format that they teach you? Because this actually varies from school to school, believe it or not. In other words, the Vertex format is like this. Right?
Yes.
Okay, we could put it in that if we wanted to. And
Hold on, let me figure out what it's supposed to be in.
well, it's probably your general format is probably this.
All it says is like find the standard form of the equation of a parabola for x plus y squared equals 0. That doesn't make sense.
Well, it doesn't really matter what form we put it into. It doesn't matter whether we use this form or this form, as long as we can identify the vertex and the focus. Let's use, I kind of don't like the way they do this. If I open my pre-calc book, the equation it is going to give me is this one for the general. It's 4a times y minus k, k always goes with y, is equal to x minus h squared. Now, the beauty of this format as opposed to the one above it is that k and h are the vertex of the parabola and a is the focal length. Well, the distance to the focus. So if I can get it into this format, I got everything solved. I've got the vertex, I've got the focus, and the directrix is real easy if you know the focus. The directrix is just an equal distance on the other side of the vertex. Okay, so this is the format I'm shooting for.
Okay.
Alright, so let's erase this and this and this and put that format, or put what we have under that. Well, what do we have? If I try to separate it as much as I can, I'll just move the x's to the other side. And so I have y minus 72 equals 2x squared plus 24x. Now, why do I set it up like that? Because I'm going to get this by completing the square.
Okay.
Let me think for a moment here. Okay. So, how do I complete the square here? In other words, you understand why we want to complete the square here? When I complete the square here, I will be able to write it as some x minus h quantity squared. Okay, so how do we complete the square of this part right here?
So, factor it out.
Well, you got to factor a 2 out for sure, because you can't begin to complete the square until you make a coefficient of 1 on the x squared term. So I haven't done anything to change anything at this point. In other words, I'm looking at exactly the same thing that they gave us. This function, this equation right here is now equal to this. I've just moved stuff around. Now, how do I complete the square inside the parentheses? Now I'm ready to complete the square inside the parentheses.
So, do like, just do x and then...
Hold on. How do you complete the square?
Find what?
Half of the middle coefficient and square it.
So 36.
So I got to write 36 right there. Now the moment I write 36 there, how much have I added to the right side of the equation?
72.
Okay, very good. Which means I got to add 72 to the left side of the equation. Now, I've got y on the left side of the equation equals 2 times, and I can now write this as x plus 6 quantity squared. You with me?
Mm-hmm.
Still not in this format at the top. What's the next step to get it into that format?
Find...
Hold on. I gotta make the right side look like x minus h squared. What can I do to make it look like that?
Divided by 2.
Okay. Now I got the right side perfect. The left side's perfect also. Where's my vertex?
Is the vertex A?
Vertex is always HK, H comma K. Remember, I got to figure out what H and K are, and I have to figure out what A is.
So,
First of all, let's figure out H and K. What's H?
6.
That doesn't say x minus 6.
Oh, so negative 6.
Okay. So H is negative 6. What's K? What's being subtracted from the Y?
Oh, 72?
No, your O is correct.
Oh.
Remember I had to add 72 to both sides? So the left side no longer says y minus 72, it says y divided by 2. In other words, k is 0. There's nothing being subtracted from the y. Now, what is A? What does 4A equal to? Because this format up here, we need a 4A in front of the y. Well, we have the y is being multiplied by 1/2 right now. So what does 4A equal to? One-half. In other words, I can equate that coefficient with this 4A. So I can say 4A equals 1/2, which makes A equal 1/8. So your focus is 1/8 away from the vertex. Okay, so let's draw this thing. My vertex is minus 6, 0, right here. We know it opens up because it's got a positive coefficient in front of the x squared. Those are parabolas that open up, not down. And where is this point right here? If A came out to be 1/8.
Focus.
What's the coordinates of that focus?
0 or -6, 1/8.
Right. So the directrix, which is always the equation of a line, what's the equation of this dotted line here? How far?
Y equals
Go ahead. Negative 1/8. In other words, this distance from the vertex to the directrix is the same as the distance from the vertex to the focus. So I know that directrix is only 1/8 of an inch, or 1/8 away. So its equation has to be y equals minus 1/8. And that essentially answers everything. We've identified the vertex. It's at minus 6, 0. We've identified the focus. It's at minus 6, 1/8. And we've identified the directrix, which is y equals minus 1/8. And then sketch the graph, which I've done.
Okay.
Now, I'm not quite sure what you did here.
I don't know either. Just ignore it.
Now, you added 62 instead of 36. Okay. But then you added 72 correctly up here, so part of this is correct. All right. Should we look at 5?
Yeah. So
first of all, can we tell by the equation of the directrix what kind of parabola it is? Is it a vertical or a horizontal one?
it's a vertical.
Yeah, because the directrix is a horizontal line, so the parabola has to be vertical. It could be vertical up or vertical down, but it has to be vertical. What's the general format?
4a y minus k equals x minus h squared.
Okay. They give us the vertex. And in fact, they pretty much give us everything. They want it in vertex form. That's okay. Let's see if we can figure out what A is by graphing this thing. Here's the vertex, 5, comma, minus 7. Where's the directrix relative to that point?
Well, maybe positive, or yeah, positive 7.
Well, what does it say for the directrix?
Oh, negative 29 over 4.
Which is what proper number? It's minus 7 1/4. Which means the directrix is down here. 1/4 point below that vertex. Which way does this parabola open, up or down?
Down.
No, if it opened down, the directrix would be going right through the parabola. It never does that. Has to open up. The directrix is always outside of the parabola. It is an equal distance outside. Well, what is this distance right here now? 1/4. So now we know where the focus is going to be. Tell me the coordinates on the focus.
5, and then 6 and 3/4.
Minus 6 3/4. Okay, so now we're ready to write the equation. So 4 times A is 1/4. So that would be 4 times 1/4 times Y. What's the rest of it? We've got it everything but H and K. H and K are the vertex.
So plus 7.
Good.
And then minus 5.
Okay. Now, we've got the equation. This is it. It's just not in vertex form, right? They wanted us to write it in vertex form. So, how do I write that in vertex form? First of all, I can erase that. Remember, vertex form is so what is this equation in vertex form?
So 1/4.
No, the one this A, I'm sorry, I shouldn't have written it like this. I completely forgot. This A is not the same as the other A. Most books don't use the letter A, they use P for the focus. And the beauty of using P is you don't get it confused with the vertex format. In other words, if I use P here instead of A, now when you put it in vertex format, you're not confused by this A over here. This A is not the same A, because all I'm doing is converting this equation to this one. Well, in this one, A is 1. It's x minus it's x minus 5 quantity squared. I'm going to subtract the 7. There's my final equation in vertex format. And A is 1. In other words, there was no coefficient in front of the x minus 5. You see why I don't like calling the focus A? Is because it's not the same A as this. This is vertex format, which we dispensed with long before we got to conic sections. It's only when you're studying parabolas as conic sections that they use a different form for the parabola, for the equation. And it's disgusting that they use A in my book here. Maybe your book doesn't use A. Maybe it uses P.
Yeah, I think it does.
Yeah, it's better to use P so that you don't get the A's confused. All right, let's do 6. Exactly the same kind of problem, only with 6, they don't give us the vertex and the directrix, they give us the focus and the directrix. Well, let's see what we can figure out from that. Let's put the focus on there first. Minus 4, minus 3 7/8. So that is right there. Minus 4, minus 3 7/8. That's the focus. The directrix is a horizontal line at minus 4 1/8. That point is negative 4 1/8. You with me?
Yes.
This is the focus. This is the directrix. Where's the vertex?
Halfway in between.
Exactly. What's that coordinate? Minus 4 comma minus 4. Now, let's write the equation starting with 4p times y minus k equals x minus h quantity squared. Let's first write it this way. Then we'll convert it to vertex format.
Okay,
hold on a second. Yeah, I think we need to do it this way. Okay, so we know where the vertex is and we know what P is. So let's fill in everything. What's P?
Isn't that just negative 4, negative...
Oh, remember, P is the distance from the vertex to the focus, or from the vertex to the directrix.
1/2.
1/8.
1/8.
Okay, so P is 1/8. So we have 4 times 1/8 times y plus 4, because k is minus 4, equals x minus 4 squared. So now we have to take that equation and convert it to vertex form. And vertex form, again, is y equals a times x minus h squared plus k. So let's convert that. What we have is y plus 4 over 2 equals x minus 4 squared. What's the next thing I want to do?
Multiply y by 2?
Multiply both sides of the equation by 2, not just y. You can't just arbitrarily multiply a variable by a number. You can do anything you want as long as you do it to both sides of the equation. So I'm going to multiply both sides of the equation by 2. That 2 goes right there. And the final step, Here's where we're at. What's the last thing to do? Okay, so now we have this, and that is vertex form of this equation. In other words, our vertex format was a times x minus h squared plus k. Well, a is 2, h is 4, k is minus 4. Ooh, hold on. H was minus 4, wasn't it? Yeah.
H was plus 4.
So that should be x plus 4. Always. So here's our equation. And in fact, yeah, no, the minus 4 is correct for k. Now, could I have solved it without going through this format? In other words, could I have taken the information they gave us and put it directly into here? Well, I knew what h and k was, but I didn't know what a was. I knew what p was. P is 1/8. But I don't know what a is. So I kind of have to use this format and then manipulate it algebraically so that I end up with y equals some number times that squared plus some other number. And that's what I did. So I don't see a quicker way to do that than the way I did it.
Okay.
All right, let's look at the next page. We only have 10 minutes. And unfortunately, I do have another session right after this one. What is number 7? What kind of a conic section is that?
An ellipse.
Yeah, and the reason we can tell is we have an x squared, we have a y squared. Well, that's either ellipse, hyperbola, or circle. The fact that the coefficients are different means it's not a circle. It is an ellipse. And that means we want to put it into the standard ellipse format. What's the standard ellipse format?
Oh.
It's very similar to a circle. Only I'm dividing that by a squared, I'm dividing that by b squared, and the whole thing's not equal to r squared, it's equal to 1. And what is a and b? There's hk, the center of the ellipse. A is the measurement of the long radius, and b is the measurement of the short radius. So somehow I have to turn this thing into look like this before I can identify the vertices and the foci.
You have to complete the squares.
Okay. Tell me what I should write next.
So, do x squared plus, that's it.
That's okay. Let's go ahead and combine our variables. Let's get them next to one another. What do I do with that 108?
Put it on the other side.
Okay, and right now it's 0, so it becomes minus 108. Now I'm ready to complete the square. What do I do next?
Why is it 0? I thought it was...
What's that?
You said that it was 0. Oh, you're right. Never mind. Okay.
Put parentheses around it. What do I have to do to complete that square?
Pull
with me?
Yep.
So far I have not changed a number. Complete the square inside the parentheses?
So it's plus 4.
How much did I add to the left side of the equation when I wrote that?
2. 4.
No. I just wrote in a 4 that's being multiplied by 36.
So 144.
Yeah. And that's what I have to add to the other side to balance it out. Okay? Now I'm getting close to my format that I'm looking for. I've got x squared plus 36. How can I write this? Everything inside the parentheses. It's the reason we complete the square, so that I can write it as a linear term squared. What linear term is that?
Y plus 2.
And on this side we have plus 36. No. Yeah. Now what? Remember what the standard format is. It's equal to 1. That's the key. What do I do now? Hold on. I erased something I didn't mean to erase there.
Put the 36 on the other side.
How do I make that 36 on the other side equal to 1?
Subtract 36.
Nah, that'll just take it back away from the format. It's a better way to do it.
Divide it by 36?
Yeah, actually if I was going to subtract something it would have to be 35. But if I divide every term in this equation by 36, I'll have 1 over there. In other words, I'm going to divide that by 36, I'm going to divide that by 36, and I'm going to divide that by 36. Now notice what I have. I have x squared over 6 squared plus y plus 2 quantity squared over 1 squared equals 1. What's H, what's K, and what's A, and what's B, and what's C? Because they ask, in this case, about the focus. First of all, what's H?
0.
What's K?
2.
Minus 2. What's A?
6.
What's B?
1.
What is C? What's the equation that relates C to A and B?
So 36 plus...
It's not the Pythagorean theorem. It's, with an ellipse, it's C squared equals A squared minus B squared, not A squared plus B squared.
So 30, square root of 35.
Right. So C is the square root of 35, which is the answer. So let's see. Everything they wanted, we now have. They want the vertices and foci. Let's figure all of that out here in 2 minutes. Where's the center? Then graph it. Yeah, then sketch a graph, okay? So we need to start with a center. Where's the center?
It's at 6 and 1.
What's H again?
-2, or 0.
And K is -2. So the center of my ellipse is at 0, -2, right there. Okay? This vertice is where? I'm drawing X's here to indicate the major vertice, and then I'm going to draw an X indicating the minor vertice. What is the major vertice? It's A. What's A?
Horizontal. So 6.
6, okay. So what's the coordinates of this vertice right here?
Negative, 6, negative 2.
What's the coordinate of this vertice over here?
Negative 6, negative 2.
What's the coordinate of this vertice and this vertice?
0.
What is B?
1.
Okay.
Negative 1.
So what is the coordinate of this?
0.
What's the coordinate of this one?
Negative 3.
Okay. Well, I got my ellipse all figured out. That's what it looks like. And now the foci. There's 2 of them. Notice that when we solved this equation, we actually got plus or minus 30, square root of 35, right? In other words, when you take the square root of both sides, you get plus and minus. Well, that's what, I've got 2 foci here. One, what is the coordinate of that foci?
It's like more than 5.
Plus root 35, comma, minus 2. What's the coordinate of this foci?
Minus 35.
Minus 2. And there you have it.
Cool.
In other words, we have everything they asked for. We have the vertices identified, all 4 of them. We have both foci, and we can sketch it.
Cool.
All right, I got to run. Good luck on the rest of it. It does get a little harder from the last few problems I'm looking at here.
Yeah.
Just, you need to know what the equation for eccentricity is. That's C over A, I believe. But better look that up in the book. All right, Jade, I got to go.
All right, have a good night.
You too. Bye-bye.